Computer language. A computer is an electrical machine, which means it uses electrical switches to work. It is comprised of a very large number of tiny switches called transistors, which are either open or closed, on or off. As computers became more complex, more and more transistors became necessary to store information. Integrated circuits, or chips, were invented to hold more transistors. Modern integrated circuits contain up to 40 billion transistors. That is a lot of information. Inside the computer, all information is stored as what is called bits. A bit is a single unit of information. Each bit can only be set to one of two values, 0 or 1. A bit is shorthand for a binary. Bi is Latin for 2 digit. Each transistor stores one bit of data, since they also have one of two options, 0 or 1, on or off. Machine languages are written in zeros and ones and are the only languages which a computer can actually understand.
Abstraction is a way to represent essential features without needing to know or understand all of the background details. For example, when you drive a car, you only need to know how to use the steering wheel, the pedals, the gear shift, etc. You don't need to understand how the engine works or how gasoline makes the car move. The driver only needs to focus on driving the car. When you bake a cake, you don't need to understand how your oven works. You don't need to understand the electronics on the inside. You just turn the dial and the inside of the oven heats up to the desired temperature so that you can focus all of your energy on baking a delicious cake. A map contains less information than the real Earth. Therefore, it is an abstraction. Its purpose is to help us find information on it more quickly than we would be able to searching the Earth. Through abstraction, high-level computer languages were developed, which were easier for people to understand. These languages could be translated into machine language by a compiler. The computer then executed the machine language code. So here, the abstraction, we have high-level language. Print hello world. Humans can read this easily. Then it becomes ones and zeros through the compiler. It becomes machine language, which computers understand.
The first programming languages, as we know them, began appearing after the compiler was invented in 1952 by Grace Hopper. A compiler acts like a translator between the programmer and the computer. It takes a higher level language, COBOL in Hopper's case, which is easier for humans to understand, and converts it to machine language, which a computer can execute. COBOL paved the way for new ways of programming, such as Fortran in 1957. Fortran was the first of the third-generation programming languages that utilized actual English words and syntax. Programs would be written in Fortran using English characters, then manually sent to a compiler that converted the code into machine language, which could then be sent into the computer to execute the program. The compiler not only converted programming languages into machine code, but also, and more importantly, it debugged programs. Debugging is a critical reality of programming since errors, or bugs, are an inevitable feature of writing code. Finding and fixing those bugs, also known as debugging, is an integral aspect of coding. The compiler greatly decreased the amount of time programmers spent debugging by detecting errors and letting them know on which line of code they occurred. Today, a compiler is built into almost all IDEs. With this, we are able to write code, compile, test for errors, and execute all within the same environment. Essentially, we do not worry about compilers anymore because they're always there. The program will not run or execute until it passes successfully through the compiler. If you would like to read more about the history of computers, check this out. Even with the invention of the compiler, programming in the third-generation languages was not easy. In the 1970s, two researchers at Bell Labs created the C language, from which many of the languages we use today are derived. Also, about that time, object-oriented programming made it easier for teams of programmers to collaborate on large, complicated projects. So what did the first programs in the 1970s do? Simple. They commanded the computer to output to the screen. Hello World. Hello World is the first program in the original book on the C language, and it has become the traditional first program in most programming courses. It may seem rudimentary now, given what programs can do, but back then it was huge. It changed programming forever and made it more accessible and possible for anyone to learn it. This is the first program every new programmer creates to this day.
Just as there are many languages spoken around the world, there are many languages used to code. While they are different from one another, their basic logic, reasoning, and constructs are similar. Learning one will make it easier to learn the others as needed later in life. Some languages include Java, HTML, C++, Python, JavaScript, PHP, SQL, Pascal, Visual Basic, C, Ruby, C#, Objective-C, etc. By the way, Java is not the same thing as JavaScript. They're actually very different. Here's an illustration of the levels of abstraction for programming languages. At the very bottom, we have machine code, which is low-level computer language. This is what computers can actually understand. At the very top is graphical language, which is very easy for humans to understand. And your computer hardware itself also has levels of abstraction. At the very bottom, we have transistors, which can be on or off, ones or zeros. And at the very top, we have a computer that humans can use.